coefficients. And so in this case, the log odds of purchasing a new vehicle, I'm sorry, I can't. Right. I think there's something to be able to do that. What we want to do is we want to look here at this B column, and all we're doing is we're taking the values in our B columns at the 0.078, and we're going to multiply it by income right next to it. 0.181 times my oldest vehicle, 2.014 times my child, minus 11.332, and that's our constant. So that's where I'm getting the figures for my regression equation. So the figures for my regression equation are just coming directly from here. So that's where I got my regression. So the natural log of the odds of purchasing a new car are just equal to that. But what I can do is, I know with logs, if I'm taking the natural log of A, if instead what I do is then I take E and raise E to that power. Okay. So if I raise E to the power of the natural log of A, that is equal to A by definition. Okay. And so in this case, if I raise this equation, if I raise my regression equation, and I take E and raise it to that power, then I actually get the odds. And so these are equivalent statements. But now if you tell me how much income a family has, you tell me how old their oldest vehicle is, you tell me something about their house or their family situation in terms of are they expecting a child or do they have a child during the year, what we'd be able to do is tell you what the odds are of them purchasing a new vehicle. And if we found that the odds were greater than 1, we'd actually predict that they would purchase a new vehicle. If the odds were less than 1, we would actually suggest that, in that case, they would not purchase a new vehicle. So that's actually how we make predictions, is that we just put our values in to this equation. So we take E, raise it to the power of the regression equation, the value of the regression equation. And if those odds are greater than 1, we predict that they will do whatever we're wanting them to do. And if it's less than 1, our prediction is that they won't engage in that activity. Any questions here? Well, as I suggested, we're going to analyze this basically like how we've analyzed a regular linear regression. Just that some of the steps and some of the procedures are going to be a little bit different, but the idea behind them are going to be the same. So our second step So our second step is to determine the statistical significance of the coefficients and interpret those coefficients that are statistically significant. Now this step is exactly like what we've done in terms of the idea from multiple regression. What we want to do is we want to see whether or not the coefficients for the independent variables are statistically significant. at 1%, 5%, or 10%. Okay. So we're going to check to make sure that they're significant, or they could be insignificant. And for those that are statistically significant, we wish to interpret them. Okay. Now the interpretation is going to be a little bit different, so that will change. But the idea of statistical significance actually is exactly the same. And the way we determined statistical significance before was we had a decision rule. So So to determine statistical significance, we're just going to use the decision rule that we developed in multiple regression. And what we're going to do is we're going to check this. So we're going to check the statistical significance by looking at the sig for each independent variable. And basically what we were doing is we were comparing it to an alpha of 0.01. When we asked the question, is sig less than 0.01? If it was significant at the 1% level. Then we asked, is the sig between 0.01 and 0.05? And that was to test if it was at the 5% level. Then we asked, is it between 0.05 and 0.1? That was determining if it was at the 10% level. And then finally, if it was greater than or equal to 0.1, then it was statistically insignificant. The same rule is going to apply here. So I'm going to go back to my output. I'll put that back up in just a minute. But what I can do is I can look here. Here's income. Here's its coefficient, 0.078. And if I go over here, I see that it has a sig of 0.000. And before, what we would say is if you have a sig of 0.000, you're significant at the 1% level, and the same thing applies here. So what we're testing is we're testing whether or not this coefficient is different than 0. In this case, the idea of statistical significance is exactly the same. We're asking, by asking about statistical significance, does changing the value of that independent variable somehow change the likelihood of your dependent variable occurring? If we find that something is statistically significant, what we're saying is that changing, for example, income is going to change the likelihood that you purchase a new car. And so in this case, what we find is that it is statistically significant, and not only is it statistically significant, but it's statistically significant at the 1% level. So we're very confident here that changing, in this case, changing the income a family has does change the likelihood that they will purchase a new vehicle. And actually, in this case, it goes with oldest vehicle. The older the family's oldest vehicle is, we think that's going to change the odds of them purchasing a new vehicle. And for child, its sig is 0.001. That's also statistically significant, 1%. And so we think all three of these variables in this case. So all of our independent variables are statistically significant at 1%.